Hello, everybody. When we are doing object oriented design by using programming languages like Java, we can follow solid principles to make cleaner design, cleaner architecture for our applications. Solid principles is an acronym. If you look at solid, S means single responsibility principle, O means open closed principle, L means Liskov substitution principle, I means interface segregation, D means dependency inversion. We will look one by one. We can incorporate these principles for an use case. If you look at, I am taking a use case called ride sharing. So when we are building ride sharing application, let us see how exactly these solid principles we can incorporate to make a cleaner design. In this application, I have identified four core entities. One is driver, rider, trip, payment. Around these entities, we will try to build the use case as well as the code and functionalities by incorporating these principles. First, let us see what is single responsibility principle. In shortcut, we call that as SRP. Single responsibility means a class should have only one reason to change. In single responsibility, we should not mix multiple functionalities in a single class. That means for any reason, if you want to change a class, it should have only one reason to change. I will show you a simple class which we are going to use to create this ride sharing application. So here I have created trip manager. This trip manager is having multiple functionalities. Here we are having create trip, which is trip management, and calculate fare, fare calculation, and send trip notifications. That means there are three functionalities are incorporated in this particular single class. For any reason, if you want to change, there is no one reason. There are multiple reasons to change this class. If I want to incorporate single responsibility principle, then I can split this class into multiple classes so that each class can have a very related functionality so that it is very cleaner, and writing unit test cases for that particular class is very easy. And if we want to change any class for any reason, we are not going to introduce any defects. So that is the cleaner design once we apply single responsibility principle. So here the same class I have split into three plates which manages the trip. The other one is fare calculator service, which is going to calculate only the fare. Third one is notification service, which sends the notifications. If you look at these classes after applying single responsibility principle, each class is having the similar functionality. For example, trip service is managing only the functionality related to trips. Notification service is having the functionality to notifying about the trips. Whether it is email communication or SMS, it doesn't matter. It is having only the notification related functionalities. And fare calculator is having calculating the fare for a trip. It can be maybe the pool ride or a single ride, multiple stops. It can be anything. So, but this particular service is having only the fare calculation responsibility. Once we have very specific classes which handles the specific functionalities, the beauty is we can have unit test cases around these classes, their classes, and they are not error prone. If for any reason tomorrow if you wanted to change the functionality, there is only particular reason. If I wanted to change the calculation of a fare, I will come and change here. Whereas in the previous example, This particular class will undergo massive changes because it has multiple functionalities inside this class. So this is the beauty of single responsibility principle. In next video, we will talk about open closed principle.